Alright guys, we're going to go ahead and start in on continental drift, otherwise known as plate tectonics, and I'll explain why it has two different names. But I have a question first. Looking at this little comic strip, how much do you think, with our understanding at this point, knowing that, about plate tectonics a little bit, how much do you think the continents, or the plates I should say, are moving on average every year? Let's take a look at someone else's answer here.
All right, question for you. Like with plate tectonics, you've heard of plate tectonics and continental drift.
Yeah.
And the continents are moving. Are they still moving today?
Yeah.
How much do you think they move?
About an inch per year.
About an inch a year? Okay.
That's actually remarkably accurate. You did a really good job on that, answering that. Here's a way of thinking about it. The plates drift, they move about the same speed as your fingernail grows. Very slow, right? But I don't want to get right into that right away. I want to talk about how the whole theory came to be. And it started with this guy right here. It's a German meteorologist. His name is Alfred Wegener. Since he was German, we pronounce that W as a V. And it seems kind of strange here to think that a meteorologist, somebody who studies the weather, developed what he called the continental drift hypothesis. Studying weather and then talking about how continents move doesn't really seem like it'd be something he'd be doing. And in fact, most of the geologic community did not accept his hypothesis. Probably a lot of it had to do with the fact that he wasn't a geologist. Probably some of it had to do with, although I can't say for certain on this, I don't know enough about this, but I could probably guess that early 1900s up through World War I, World War II, at least in the U.S., Germany wasn't on good standing conditions with us, so that may have had a lot to do with the slow acceptance of this. But there's even a bigger issue that happened that kind of made it not be accepted, and that's what I'm going to end this lecture on. So we'll get back to that. Hold that thought in the back of your head. I want to tell you what proof he used to support his hypothesis. So here are the proofs that he used. First, let's establish this. He said that all of the continents at one point, about 200 million years ago, were all together in a super landmass called Pangaea. Alright? And ever since then, for the last 200 million years, these continents have been drifting apart. So how does he prove this? He says, one, they fit together like puzzle pieces. I mean, look how perfectly South America snuggles right into Africa. He said, is this a coincidence? And he thought, no, it's not a coincidence. That there's a reason for that these were actually once together. Right? He wasn't the first one to make this observation. Other people have made this observation. But he had more proof to go along with that. Proof number two. We're finding a lot of fossils on on South America, say, like this plant right here, found in South America, and then it's also found over here in Africa, then over here in India, and Antarctica, and Australia. Here it makes sense if all the continents are together, but when you spread the continents out as they are today, how did that plant get from South America to Africa? Well, it's a long ways to get for a plant to walk or swim across the ocean, right? So he said, well, logically, these continents must have been together, because it's not that unrealistic to think that seeds can blow across the land. And there's other fossils to support this. We're going to do a little lab activity. We probably already started it a little bit in class dealing with this. All right, number three. He noted a correlation of mountains with the same age rocks, same type of rocks on one continent that seem to end right at the ocean and then pick up, several thousand miles away on another continent. Now, why is that? It would make sense, say, for example, if there were mountains coming down through South America here and just ended right here, or just rock formations, and the same rock formations picked up over here in Africa. It makes sense if you snuggled those together, like he said in the first evidence. So this piece of proof also helps support that. He also noticed, I'm going to kind of clump two things together in evidence number 4. There's a lot of people finding rocks with glacial scarring. When a glacier moves over rocks, it'll scrape it up in a very like fingerprint kind of way. So a geologist will know, hey, these are marks made by a glacier however many years ago that went over here. Well, they're finding these glacial scars on rocks in tropical areas where glaciers don't go. So logically, what Wagner said is, hey, these tropical areas are tropical now, but 200 million years ago, this land was more at the poles where glaciers do move, and they've drifted away from there, bringing with them the evidence of glaciers. Makes a lot of sense. On the other side, here's the other evidence I wanted to clump in here, the reverse, a little vice versa here. We find oil, coal, stuff like that in very cold areas. Now let me explain something. Coal is formed from tropical plant material, usually gigantic ferns, types of plants that really are abundant in the tropics. What will happen is they'll die, they'll get covered up, and over hundreds of millions of years, 100 million years, 200 million years, the decomposition of those plants actually forms oil and coal. Right? Now, why is it that we're finding coal in very northern regions, Pennsylvania, even further north, like northern Russia, like Siberia, somewhere like that? Why are we finding coal in these very northern areas if we know that coal formed from tropical plants? Well, the answer is those areas weren't always far north. They have drifted there. They were once in the tropics, and they brought with them the decomposing plants that turned into coal. So those are the evidences I want to talk about. I said I'd end this lecture saying the main reason why most geologists did not accept Alfred Wegener's hypothesis. He had all of these good proofs that there was a Pangea and continents have drifted, but he was missing one major ingredient that he never found during his lifetime, and that is, what is moving the plates? You can't just say a continent is drifting if you can't explain what's pushing it. You need a gigantic force to push it, and he could never explain that. And the explanation for that didn't come until after he had passed away. And that's where we'll pick up on the next lecture. All right, we'll talk to you then.